told, I think, therefore I am. If I think, I exist. What actually it means you understand, but how to prove that entire world exists? If exists only I or entire world. So you need to make a second logical step, which is second derivative. I told that I think, therefore there are also other people like me who understand my language. So by this logical step you can prove that also other people exist. And if people exist, they are very similar. They understand my language, that's why they more or less similar with me. Otherwise they will not understand me. But looking around, you can see that stars are also similar between each other. You can find that cars on the street are similar, chairs in this room are similar, and houses in the street are very similar. A lot of similar objects around you. And the question is why? There is also a second level of similarity. Similarity between different similarities. Like if A not equal to B, but A equal to some other A, B is equal to some other B. These two facts also somehow similar between each other, even if A and B are not similar. Yeah? Now, let us explain it by physics.
Can I ask a question for you? How are you defining similarity? Like, what do you mean?
Let us run quick because it's 40 slides more and only 20 minutes. But later I will answer. So, if you have a hot and cold body, what happens in physics? You put them in contact. What happens? They exchange heat and then equalize heat. What it means? It means that in certain sense, these two bodies become similar by themselves. So in nature, in physics, this process goes by itself without any help of anybody. The other example, you have two lakes connected somehow. These lakes have different water levels. After a certain time, it equalizes. The same story, two lakes become similar in certain sense. Not totally similar, but in some sense they become similar automatically by themselves. All this process in physics is described by entropy. They say that in such case entropy increases. Just open books, read what is entropy. It's a very, very significant item. You will discover a lot of interesting about this. It's not in doing physics or mathematics. It's very interesting. So, it was proposed by Rudolf Clausius. Actually, entropy can be defined as the amount of information that has been already forgotten and lost its value. So if you forgot something, it's entropy. And for example, you met somebody, some group of people. First, you remember their names. After a certain time, you forgot their names. What it means, actually, they become similar to each other for you. It's a definition of similarity. If you do not know information about how they are different, if you have forgotten it, what happens? They have the same faces in your imagination. For example, these people, yeah? But what is interesting, they all have a similar jacket. What I want to say, the fashionable jackets become the same automatically by the psychology of people. Because everybody wants to wear something fashionable. But if you take two totally different objects, like a jacket and a chair, and the question is, if these two objects also can somehow become similar, do you believe?
Yes.
How they can become similar?
I think when the history goes on, and sometimes people are going to look back and going to think that chairs and jackets, this kind, like something of the old people, and they're going to be similar in this way.
Or maybe yes.
Or both will be recycled and new.
Yes, exactly. If both of them goes to will be recycled, it means you have forgotten what it was exactly. You simply forgot. It's full entropy and achieve its maximum. It means entropy achieves its maximum. Full chaos, yeah? So, now, what you should understand about entropy. Rule. Growth of entropy is inevitable, always. You cannot lower the entropy of the system in which you yourself present. And if you care about future of our planet, the answer is very simple. Friends, you better do nothing. As soon as you start actively do something, you destroy this world much more than it is destroyed
Can you
already.
wait one second? I didn't manage to finish reading it.
Sorry?
Could you go back one slide so that I can finish reading it?
She should also
One
read it.
second. Again.
Again, please?
Yeah.
One question.
So if you want to clean something, you take garbage from this place, clean it, and put garbage in the other place. But garbage do not disappear actually. So you make the other place even more dirty. And not only about garbage, with everything it is like this.
But with pollution, you can sometimes reduce it without creating more in another place.
It could be. What I say should not be understood absolutely. But it's a general idea for your imagination to think about. For example, struggle of revolutionaries for happiness of entire mankind lead to suffering of people. Throw some Molotov cocktail, yes, something like this. Entropy of their country increased definitively as a result of this revolution. Everybody become poor. So, the other example which can concern all of you, sometimes you try to improve your health by using some medicine. What happens? Sometimes by strong medicine you increase entropy of your body. Finally, you destroy your body. And this example is not very understandable, but you know that struggle for use of green energy leads to increase of corruption. It is known effect. I don't want to stop here and.
Can we discuss this fact?
This fact we can discuss, but I need a special seminar to discuss this fact because people do not understand. When you travel in Bayern and you can see wind generators which stays, they don't rotate at all. It's very common situation. Try to ask why this generator stay in place where is no wind at all, most days of year. Why? Because it's corruption. That's it.
Okay.
But don't stop on this. If it is an interesting item, I will prepare a special report about this. So, ability to discard and forget unnecessary information is the most important property of your living mind that distinguishes a human from computer. That's why people think, but computer only process information. This is also a very significant message. We have here a seminar about artificial intelligence. One big difference between computer and human. Human can forget information. Simply forget, and that's it. Computer never forget. Never. So I would say for humans, forget and forgive, it's very similar English words. Noble people should be able to forget and forgive everything. Otherwise, your life will be finished somehow. Because those whom you do not forgive, they will kill you. So be accurate. Forgive proper time. So, now, conflicts. In the beginning of some conflicts, of course, there is a hero and there is dragon. Yeah? Good fight against bad. What happens after 3, 5, or maybe 10 years of conflicts? Try to guess. Entropy increase, which means that both sides become the same. Absolutely the same. By the way, Syrians do not understand it. Why? Because it's not enough time, probably. After 10 years, you will understand this message. When you understand that both sides which kill each other, they are absolutely the same. Oh, he understands. Maybe. He don't believe, and you believe, yeah? So who believe? Just let's vote.
You can just compare the both.
I tell you again, of course they are different initially. After 10 years, they will be the same.
Yeah.
Absolutely. Don't worry.
Okay? Now let's return to physics and thermodynamics. I want to emphasize very interesting message. I wrote invoice, it's just a joke, of course, but you can see three different languages here. In thermodynamic language, you use word entropy, temperature, and energy. Entropy, temperature, energy. In theory of information, for the same things you use words. Amount of forgotten information, which is entropy. Price per megabit, or price per some page, or per one unit of information. And total cost of information, how valuable is this information. In economic language, it probably will be amount of used goods, price per piece, and total cost, like an invoice. Example, price of 1 unit of information have tendency to level, the same like temperature. By the way, all objects in this room have temperature 25 degrees. Why? Do you know why? Because they exchange heat with each other. The same happens in the market. Why barrel of oil costs in Russia the same price as in South America? Why? Because they exchange everything and finally all price come to the same level, the same as temperature. So it's in case of newspapers, you always pay €3 for some amount of information. 6 pages of information cost €3. What is inside doesn't matter. Probably the same stuff, like some scandals, some life of rich people, or some refugees problems, and so on. Something like this. Whatever you buy, you will see the same stuff. So it costs €3. But we know in history that sometimes it is totally different. For example, I just make a reference, but you can read yourself. Nice story about Rothschild. 1 bit of information, just yes or no, was so valuable in certain moment that he made his billions of that time probably pounds. He made an absolutely huge amount of money just using 1 bit of information, which was if Napoleon win or he lose. Yes or no? Just 1 bit of information cost billions. Very simple message. Amount of information and value of information is 2 totally different things. Amount of information can be small, big. It depends how many megabytes is there. Value of information, it is how you use it, and if it is really valuable. So, now let us calculate energy. I have matches, just match. Weight of this match is 1 gram. 1 gram. Yeah. I use very well-known formula to calculate how big is energy of this match. So I did these calculations, very interesting result.
25 million kilowatt hours.
You can understand it is enough to supply with heat entire Munich during a month at least, or maybe few months. Absolutely huge amount of energy in this 1 match. Okay, Einstein formula give you a result. Really funny. Yeah, so it should cost in the market something like €1 million. So I make you offer. Buy it now. Now. Wonderful. Do it. No? No, yes. See, such big amount of energy is in this match. Oh my God. Understand? Joke? Okay, so what is the matter? Why this formula is not valid? Why it gives so big result is because here is a c is a speed of light, and speed of light is very, very big. Yes? You should understand that this is actually dead energy. Energy which cannot be used. This energy exists theoretically, but not really. Real energy in 1 match is something like this. I have calculated for you 0.004 kilowatt hour, which is very, very small fraction of energy which gave by first formula. 1 with 10 zeros, something like this. By the way, just one remark about this. which was not initially in my slides. I would say the same story people from church tell you. When you die, you exist somewhere, somehow. This energy also exists somewhere, somehow. Nobody knows how, but this energy exists only theoretically. You cannot take it back somehow. Okay, now, entropy always increase. From the beginning, from Big Bang, entropy increase, and now today it achieves some level, very close to maximum. I cannot draw it here, but you should imagine that distance between close to max and max is 100 millionths time or 100 billionths time closer. Please?
Why do you assume that we're already this far
Sorry?
to the maximum entropy?
Sorry?
How do you assume, why do you assume that we're already this close?
Calculation is very simple. It is just relationships between energy which you really can extract from this match. You can extract, of course, a little bit energy. Yeah? There is energy. But if you compare this energy with this theoretical energy, which comes from Einstein formula, it gives you idea what is the difference between maximal entropy and compare it with total entropy which was already achieved in this universe. See, yes.
You can go first.
By the way, entropy increased again, and in this match even less remaining.
That's why do you assume that after the rate of changes, entropy changes suddenly? Like the rate of increase is suddenly going down.
Sorry, again?
Why is the rate of increase going down after today?
It is a rule, I speak to you about physics. It's a rule known as a physical law. It increases, and fast achieve its maximum already. In all objects in the universe. That's why you see so many similar objects, like cars, people, and so on. I tell you that, for example, in this air, there are atoms of oxygen. They are also very, very similar between each other. Just for the same reason, because entropy of the universe is already very high.
Is it increasing like in logarithmic scale? Because that looks like a log graph.
It could be something like this, yeah. Sorry?
Okay, but if you think that entropy, as you say, is there how things look alike and how things are close to each other, and then shouldn't be in the start of the time, so in the Big Bang, everything was kind of the same, and then things got differently, and now they're going back to the same?
It looks like in Big Bang, everything was not very the same, was lower, of course. We don't know exactly, but it was much lower.
That say that in the beginning there was not so much atoms, not so much, because now we have a lot of atoms and a lot of different materials, and in the beginning it was like one or two, and then more were beginning with this.
I understand what you mixed about. There's a process called condensation.
Yes.
And it will be a little bit lower. I will explain you. Let me now discuss similarity of two objects is always relative. What it means? Objects have something in common and something different, like you see. Always something in common, something in different. For example, these young penguins, there are penguins here, yeah? These young penguins are all the same for people. No difference, you cannot see any difference. But very slightest distinctive information which make it possible to distinguish their child from other children is extremely important for parents. So when parents come from sea with a fish, they give it only to their child, not to anybody else. This is a rule of nature. And for parents, of course, very slight difference between their child and somebody else is very, very significant. So value of small amount of information is very high for penguins. Yeah? There's an example which shows that energy also is some relative value. For example, you have some astronaut which has some object, I don't know, maybe this button. And when he flies together with these objects, kinetic energy of this object is not really big. It's very small, practically zero. In the inertial system, in which they both fly in spacecraft. But for those who stay on the S, the same object have a huge kinetic energy, as usually mv square divided on 2. What it means, actually, it's the same situation as with the penguins. So there are some similarity between kinetic energy and penguins. Really strange. But both situations are similar because they both illustrate that value of information is relative thing, not absolute. But it contradicts to our everyday experience. After all, there are true value in the world. For example, United States dollar is valuated everywhere. The same even in Africa, everywhere. For example, sunlight bears equal energy to everybody. You can imagine there are some absolute values. But not if you look deeper on situation. You can understand that absolute value is always some illusion which comes from the fact that all observers themselves become very similar between each other in the result of growth of entropy. You value United States dollar exactly the same as I, just because we are similar. If some extraterrestrial aliens come, they say, what? United States dollars cost nothing. No interest. And the same is with energy like sunlight. If some astronauts flies with very high speed away from sun, according to theory of relativity, he will see that this sunlight will be darker, much darker. So, for contrast, you should understand that amount of information do not depend on observer. So, amount of pages in this newspaper for you and for me is the same. Now, very interesting physical experiments. You have seen it every time when you open Pepsi Cola or maybe champagne. You see some condensation, like some fog come, which means that molecules glue to each other and create some small drops. This is exactly what happens after Big Bang. Yeah. So, what happens in such case? Initially, just when you open bottle, the volume increase, and what happens with gas? It becomes colder, always, because it makes some job. What happens with entropy at this first moment? Nothing. Entropy remains as it was. What happens with temperature? Temperature falls. Okay? Then starts condensation, initially a very small droplet, and then bigger drops. What happens with entropy? In this situation, entropy starts to increase. So as soon as condensation goes, entropy increase. Meanwhile, the entire volume is not more so uniform as it was. Still entropy increase. Why? It's physics, we should discuss it separately, but entropy increase exactly when you go from this situation to this. And if you simply increase volume, entropy do not increase.
Sorry, entropy between what and what?
Entropy of system as a whole.
But what are in the system?
Right now I speak about system which consists of
The bottle and the liquid.
air and some water which was dissolved in this air. There is no drops initially, but then they appear when the temperature goes down. Temperature goes down, starts condensation. When condensation starts, what happens with temperature? Temperature increase. And this increase of temperature is the reason why entropy also increases.
Because for such system, increase of temperature always means also increase of entropy.
If you speak about Big Bang, also when gas concentrate in some stars, temperature increase inside stars. Okay, so very similar situation. I don't know if it is visible or not, but here is a satellite picture from night Earth. And you can see that our civilization also condensates in some cities. We do not live uniformly on the surface of the planet. And the reason is actually expansion of European civilization. In Africa, nothing like this happens. They still relatively uniform distributed because they simply live in wild nature, and that's it. Okay, last message is hierarchy of food chains. So how can we lower the entropy? Sometimes entropy goes down. You know, in a refrigerator, of course, entropy goes down. But it's always about this situation. You have two objects, 1 and 2, which have some flow between each other. And these two, A and B, try to become similar. And you can have a third object which, using this process, can diminish its own entropy. For example, this is how water turbine works. Two legs, and turbine stays between. What is interesting to emphasize, you should understand that these legs will become similar also without turbine. Turbine do not help them to become similar. But turbine, like some parasite, use this process. The other example, very funny story happened in Russia. There was some plagiarism. Some Russian singer used the same melody as this French singer. And this French bring him in the court because it's plagiat. So it's very easy to understand that these two try to become similar for some reason. Plagiat is the same story. They try to become similar, to sing the same melody. Who make profit? Of course, judge. Yeah, it's very easy. I hope you understand this. I don't know. He don't make any profit, and this also make no profit. Only expenses. Finally, he lose the case. This one lose the case. And honestly speaking, I understand why. Reason is very simple. Okay, if we return to this previous picture, you see these two objects, and third, there is one more object in this picture. You don't see it, but it is entire our planet, which make a gravity. And because of gravity, it increased process of equalizing of level of water. With music, it's the same. There are two singers, and there are public. And public want them always sing the same melodies. Because it's psychology of people. You do not want new melodies. Forget about it. You want always to hear the same melodies. And that's a reason why Philippe Kirkorov should make some plagiat. Otherwise, his music would not be accepted. It is absolutely natural process for music because it's a basis of music. Without repeating of the same melodies, music do not exist at all.
But wouldn't I get bored if I hear the same melody from
you do not get bored, don't worry. Okay, so, no, believe me, if you hear something absolutely which you haven't heard, you will get bored much quicker, much quicker. You simply say, oh, no, I cannot hear it, something. Okay, so in life, it always like this, it's food chain, like sun make a radiation, and the grass on the surface of planet make a profit. Grass dies in stomach of cow, cow make profit, cow dies, butcher make profit. Butcher sell meat to some customers, bank make profits. So you always see this situation. Two objects try to become similar. In this case, sun try to equalize its temperature with out space. Yeah, here is something like 5,000 degrees, and here is something like 4 Kelvin degree. Space is very cold, so they try to equalize temperatures. That's the reason of sun radiation, and grass make a profit from this. And message is for you. Do not be grass, do not be empty space, do not be a lake, be a turbine. Be a turbine. So use a situation when you see two people try to be similar for some reason. Use this situation and be over situation. Then you can diminish your entropy. If you are involved, if you are one of these sides, you are losers always. So it's very significant message. Think about it. So, question for discussion. Please evaluate amount of entropy in my message. just in percent, you say, I know it 100%, I know it's nothing new, or maybe I do not know half, the other half I know. So just give me some percentage.
It's all the information that's lost by now.
No, it's not about lost, because it's amount of information which is not new, actually is empty information, which do not have any value.
Everything in this presentation was new, 100%.
Everything, 100% new. And you?
For me, only the concept of entropy in the physical sort of thing wasn't new, but the rest was also new. Like the way you applied it on different aspects of society.
So something like a percentage, just.
90%.
90%, okay. Other opinion? So, okay. So, by the way, consider to discuss between each other what is optimal concentration of new information to make it interesting. I suspect that for information to be interesting, it should repeat something which people already know. So it is not correct to say that 100% of what I told is new, because language what I use is not new for you. So, and so on. How long it takes for enemies to become similar? Okay, I told it maybe 5 years. Maybe you have the other estimations. This friend told never, but maybe
13 years.
You said 10 years.
10 years. Not 5, but 10 years they become similar. No, I just say maybe 3, maybe 10. I don't know. Just what do you think? What is? What I suspect it should exist some universal time constant for all kind of conflicts, because all conflicts are similar.
Yeah, until both have equal powers.
If they both have equal powers. So how many years?
It depends on the situation.
No. So you don't believe that there is some universal concept?
The Russians. Then the Russian experience, so it would be easy for the others too.
Okay. Are all religions similar? What do you think?
Yes. No. Yeah, because they are.
He told no. Why?
All races are not similar. They have their own different beliefs and stuff.
Because people.
Yeah, but they always believe something. That's the
So yeah,
system.
it's different. It's faith. They all
No, at least you say that maybe they are a little bit similar, but in principle they are very different. In most. So concentration on entropy in your evaluation is something less than 10%. All other are different. Yeah? So okay, maybe. No, let's see your opinion. So your ideas for discussion.
Can I discuss something?
Yes.
I need like 5 minutes. Okay, so as you say, that entropy means that in the end everything would be similar and equal. Like every force in the world would equal each other, or end in the same sense.
Maybe yes.
Then, in my opinion, this means that there is no entropy. Because no entropy. The theory is wrong. Because we have only 3 situations in the world. There is no 4th situation. So, as the Big Bang Theory suggested, that everything started from the singularity, that is one point, and then it's expanded. Anybody heard about this theory? Big Bang started from a singularity of time, there was no time, no space, and everything expanded from it. And some theorists say that in the end it would be also that the world would condense to each other and it would be again the same singularity, the same one point. So we are either in the beginning, just the fresh beginning of time, or the fresh end of time, or now. Now we don't have anything. I don't think so, because we are not very similar. The laws that govern us are similar. We dress in clothes look like each other because we don't want to be cold.
Yeah, but we are a subject of the same force from...
Exactly. But are we really similar? Exactly no.
Exactly not. Not exactly, but we are very similar, I would say.
Yeah, but if you say that in the end, the entropy will happen because we return to the same point, then there is no entropy because there is no 2 points to be similar to each other, and there is no observer to observe the same.
Yeah.
Then there is no entropy.
No, there will be nothing when nobody will watch it.
Exactly.
Yeah, but
Yeah, so if there is no entropy here because we can't, there is nothing, two things that are similar. It's one thing only. If we are here in our nowadays, we don't look similar, there is no entropy. And in the end, again, there is nothing to compare to and no observer to observe entropies, then there is no entropy. Yeah, just, yeah. Yeah, just came to just wanted because there is camera, so.
Big breakthrough.
okay.
Yeah.
No, no. Actually, you can read many discussions. Last time I read, for example, book of Penrose. He discussed it, Road to Reality. But you also can find that discussion about entropy.
Yeah.
So initial point and finish point are not the same. They are totally different.
We will end the same according to entropy. So it will be one singularity that is condensed again. Or it will keep expanding the universe. In both ways, there is no entropy. There is no observer at the end.
Yeah.
Do you really need an observer for entropy?
For a theory, you need the observer that will define the theory.
No.
But
Yeah.
it's a physical
It's a physical,
measure.
yeah.
It's like-
it's energy per temperature.
Yes, but then if it ends in the same point, then there is no point. 2
Of
points are
course, you
available.
can compare the beginning with the end.
Yeah, but it's also, it's like, because I think in physics it's really ln, like the logarithm of, so you have the Boltzmann constant times the logarithm of the Zustands, so different states. And if you just have one state, I think that was the definition of entropy, I'm not too sure, but if you just have one single state,
Then it's
the
entropy.
logarithm of 1 is 0, and therefore entropy is 0 if you just have one state. And if that was the case in the beginning as well, that you just have one state, then in both cases we have 0 entropy. But at the moment, we have plenty of different states.
Yeah.
And therefore, you cannot claim that at the moment the entropy is 0.
I think that everything is really relative. You can't just say that something is similar or something is not. Because if you look like to sand, you're going to look at sand on a beach, oh, it's similar. But if you take and look really close, it's not.
It's not, yeah.
So,
Roses, houses, the same.
yes, and we are similar. We have the same heart and hands and everything, but if you look directly to a person and another, then you're going to see that they are different. So, I think if you think about like a cup with water that is initially really warm, but then it's cold outside, then the water is going to get cold, and then you're going to say, oh, they're the same thing, because they're the same temperature. I think that maybe it's the failure of what you're talking about, because then you're going to look the same. But it's not, it's just they just have something in common. They are just
Yeah,
constant.
but having something in common doesn't mean that they are similar.
No, I have something in
But
common with
to equal
ants.
each other. I mean that they equal each other or give energy to each other.
Yes, but then what's when is entropy perfect? When there's no energy to change anymore?
For me, if there is one aspect that is different, then they are not similar.
No. I tell you what. No, stop. I tell you what. There are very simple things about this. Nothing is completely similar, and nothing is completely different.
Yes.
Just nothing. I tell you, it's two cases. If something is absolutely similar, it is just the same thing. If something is completely different but still exists, only by fact it exists as you exist and these things exist, you have something in common. As soon as you exist in the same world. So it should be always somewhere in between.
But then you can somewhat associate all things with everything. Just the fact that I now think about both antiparticles right now and some chair, this makes them similar in a way because I now think about them. So therefore you can basically just like use this definition of similarity for everything, just the same someone thinks about it. So I think what we are lacking here is one joint definition of similarity that you requested earlier as well. And
I think the third you cannot define similarity or dissimilarity, but you also have to define uniqueness then. Because without uniqueness, you cannot differentiate two things, or you cannot make two things similar.
I don't know. My message is that there is no unique things at all in this universe.
Everyone here is unique in what
It's your imagination. Sorry.
It's not my
No,
imagination.
that's
It's your imagination because you look on yourself from inside. If you look outside, you see there are a lot of men with barb and glasses like you.
Similarity means that I'm 100% similar to the other person.
No, that's
Not necessary.
Similarity
Similarity is approximately, of course. Always or two objects.
How much percent would you say that things become similar then?
No, it's measurable things, and you in each case you can tell this percentage.
For me, the beauty of this universe is that every person or every individual is unique from the other. Because if then there's like life is very boring then. If the people are very similar.
Not really. Not really.
Yeah, I think so. The uniqueness is actually given because like the atoms in your body are different from mine, and so the composition is very similar. Like in fact, like we have more things in common than things that are different, but we are unique in the sense that there's always a different composition. So it's just a matter of on which level of abstraction you look and then how much detail you look. But for like pretty much 99% of the world, the group of us sitting here right now, is super similar. Even though within our group, I would say we're completely different and unique people, and every single one here is unique. But the way how we come together in Munich, in a university town, we're all able to communicate in the same language. For 99% of the rest of the world, this is a very similar group of people. So it's always the level of abstraction.
It depends on which terms you say similarity.
But therefore uniqueness does exist, but also similarity is just level.
They're coexistent, they don't need to destroy one
Mm-hmm.
another.
Yeah. Yes. I have like one question that's related to that, because in physics and also with thermodynamics, what is happening that if two differences appear, then they even out and get more similar, and there's the gradient shows like from one direction, like from the high, also the concentration of atoms in one region. If you give them the chance to even out, this will flow into the area where there are few atoms of this particular kind. That's a chemical gradient. And whereas in a society, I think that often the opposite occurs, that people are more attracted to people that are in fact more similar than oneself is. So if you put a bunch of people from different nations with different hobbies, with different types of interests into a room, unfortunately most of the time people will mix in groups that are more similar. And therefore the opposite happens from what happens in nature, like in physics. Because there's...
No. Absolutely the same happens if you have seen, for example, all the stones of granite. You understand what? So you can see that there are some fractions of minerals, and this is a process because similar atoms look for their brothers, and actually they form some crystals. Crystallization occur. When crystallization occur, it is the same process. Crystal always cleaner than environment. It attracts only molecules which are the same.
Okay, but that's a Rathmann phenomenon.
You always see fragments of something in granite. It's just the same case, absolutely.
Actually, I really like your concept of being the turbine.
What?
Being the turbine.
You know, it's advice for young people. Yeah, don't let others exploit you. Exploit somebody.
When there's two things which are like catching equilibrium, then you become the turbine and just like raise up and see what is happening.
Yes, and by the way, turbine works in both directions. It doesn't matter which lake is higher, which is lower. You simply always extract your profit.
It does matter if in which direction the water is flowing. The direction of the turbine is based on that.
No. Turbine will extract energy automatically
And there are some turbines which exactly made like this. They works in both directions because it brings energy.
Okay, I think that was a nice closing statement. Thanks a lot for the talk again, and now we'll go on to the social part.